We're going to start this practice test that the textbook gives us, and we're going to look for strategy and what can we do. Now, we're asked to graph this particular equation. And what do we notice about it? Well, is it in slope-intercept form? No. So perhaps that would be the technique we'd want to use here. So let's put that in slope-intercept form. That'll be our first thing we're going to do. So we have 3y, that would be this one, equals x. And now I'm going to transpose this to the other side, minus, on that side it becomes a plus 6. So I'm transposing this to the other side, it becomes a plus 6, and I'm just writing it this way. So I'm going to divide everything by 3. So this now becomes y equals 1/3 x plus 2. And that's a good way to do it. So now I'll use that technique of putting a dot at my plus 2. And from that, I'm going to do a run of 3, and then a rise of 1. And then now this will be my line. And we usually make the graph the full line that goes to the edge of the graph, not just a little tiny thing there. And that's, of course, what happens in MATLAB. Now, for example 2, as we do it, this is in standard form, so I'm going to make a little t-chart, my x and y intercept t-chart. And if x is 0, we're going to divide both sides by a -1. I get y is 2, a positive 2. This is 0, a positive 2. Now, if this is 0, y is 0. I'm going to divide both sides by a 2, and this is a -1. So I'm going to plot my y-intercept. Now, I recently checked a test that was done on paper at another school, and students were confusing the y-intercept, and I won't go into it. But this is the y-intercept, 0, 2. And then now -1, 0. And then we make our line. And I'm a little off there, but your lines can be made very nicely. Okay? Now notice you have both the x and your y-intercept. So, by the way, if they gave you online graph by plotting the intercepts, this would definitely be the way you'd want to do it because it gives you the intercepts. Now, in example 3, this is set up beautifully. This is equation 2, slope-intercept. So I'm going to plot my y-intercept as a positive 4. My slope is a positive 2/3. So I've gone over 3 for the run. Now I do 2 for the rise and get my line tool. And there's my graph. Now here's a special case. And again, the strategy will be, what is this? Well, this is formula 5. Y equals B. And that's a horizontal line going through the y-axis at 2, so right there, and any other point, and we make our line, And there's that graph. Continuing. Okay, as we look at this one, they're asking us to find the slope of this line. Well, notice that it starts high and it goes down. There's a kind of a little problem here because it's not going through a grid mark here. But notice what we can do. We can cut these in half now. Now it's going through a grid mark. So we're looking for M, which is Y units over X units, or rise over run. And we know our answer is going to be negative because it's starting high. So we have here 1, 2, 1, 2, 3. This will be 3, and this is up 1, 2, 3, 4, 5, 6. And again, we said it was negative because we went in a negative direction for our 3 and a positive direction for our 6. So this is going to be a negative 2. That's the slope. And let's just add something here. What's the equation of that line? Well, we know it's y equals our slope minus 2. That's our slope, x. And it's intersecting 1, 2, 3, 4, 5, 6 at a plus 6. Now you might say, well, it wasn't originally a 6. Well, it was actually a 3. But since I made it this way, this is valid for what would have been there. Okay? Anyway, let's continue. Now, the instruction here still continues, find the slope. So we're going to put M here. And for this one, it's M and B. And then that's something else. Okay, for this one, it'll be 5 minus 4. I'm using formula 3. 5 minus that. And then negative 6 minus a negative 2. So this is going to become a plus. And this is a 1 on top. And this is going to be a negative 6 plus 2 is a negative 4. So my slope here is a negative 1/4. Now, to find the slope easily, if it's in standard form, we're going to solve for y. Transpose the 3x, I should say. Changes its sign. Divide everything by 2. And this will become a 3, but I'm looking for the slope. So the slope is a negative 3/2. Now here I had to know that y equals b is a horizontal line, and the slope of any horizontal line is 0. If it was a vertical line, it would be undefined. That's probably on another test. Here, again, we solve for y. Transpose the 2x over as a negative 2x plus 3. So again, our slope is a negative 2 here. And our y-intercept is a 3. Now another way to write that, of course, is 0, 3. That's in the form of 0, b. Now determine whether the graphs are parallel, perpendicular, or neither. Well, we have to compare the slopes here. This one, the slope is 3. Now here, as I solve, a negative x plus 9. I divide everything by 3. So for this one, my slope is a negative 1/3. And for this one, our slope is 3. Now if I multiply these, 3 times a negative 1/3, the product is a negative 1. So when that's true, the lines are perpendicular. Okay, let's bring it up a little bit. Now I'll work some of these out on the side here a little bit to speed up the tape. So here I have a slope and I have 1 point. So I'm going to use formula 4, which is the point slope form. So I'm going to put my y as 4 right there. Remember, negative 4. My slope as a negative 1/3. And my x as a negative 2. So the opposite of a negative 2 makes that a positive 2. And I will continue. So I'm just writing this again. I'm distributing this. This is a negative 1/3 x. A negative 1 times 2 is negative 2 over 3. Now, I could bring this over and then I'd have to transpose that to a positive 4 on this side. But an easier way to do it is to get rid of the fractions at this stage. And you'll see why in a moment here. So there's a 3 and a 3. I want to get rid of all the fractions. So I'm going to multiply everything by 3. So now these go away. And now I have 3y minus 12 equals a negative x, right here, negative x. And then this is going to be minus 2. Now I don't have to worry about getting common denominators and grouping this together. Now I'm going to bring this over to the other side, a negative 12, as a positive 12 here. So this then becomes a negative x plus 10. Because this on the other side is a positive 12 and a negative 2, positive 10. And this is 3y. Now they want this answer in standard form. So I'm going to move the x over to this side. It becomes a positive x right there, plus 3y, and equals 10. Okay? That's number 11, and it took a while to do it. So let's do number 12. So what information are they giving me here? Well, it says it's going through the origin, and the origin is 0, 0, and my other point is 5, negative 6. So with those 2 points, I can find the slope. And I have the formula right there. And notice this then becomes a negative 6 over 5. Now, do I really need the point slope form, formula 4? Well, no, because I have y equals a negative 6/5 x. And this is plus 0 since it's going through the origin. Okay, that's my y-intercept. But it's still not in standard form. So I'm going to multiply everything by 5. The 5's cancel out. And I then get 5y equals 6x. Still not in standard form. I have to, well, I'm going to move this over to this side here and put that as a 0. Well, I'll do it this way. So this becomes a negative 6x plus 5y equals 0. Now, I would accept that answer if they wanted it to be your a term, which is this here, negative 6. If they wanted that to be positive, you just multiply each term by a negative 1 that changes their sign. So for this one, it would be 6x, positive 6x, minus 5y equals 0. Okay, there's another one. As we work on example 13, we have 2 points, so we have to find the slope. And our slope is a negative 3/7. I'm then using formula 4. You might say, which points do I use? Well, I'm using this set. So my y is a 2, so negative 2, and my x is a 4, so negative 4. Now, we have to put it eventually in standard form, so I'm going to get rid of the fractions right away by multiplying every term by 7. Now notice here the 7's cancel out. So I now get 7y minus 14 equals a negative 3x, and then a negative times a negative gives me a positive 12. Now since I'm going to put it in standard form, I'm going to move this term over to this side already, and I'm going to get a positive 3x plus 7y. That's moving this term over here, and that gives me 3x plus 7y. And I'm going to move this over to this side as a positive 14, and that gives me 26. So again, it does take a little time. You had to figure out the slope and had to do it accurately. Then use formula 4 to substitute. And since they want it in standard form, I got rid of my fractions. This is a technique from chapter 2. And then it's so much easier to handle. And I don't have to get, 12/7 and all that stuff. Then I transpose the negative 3x to this side, and then I transpose the negative 14 to that side, and there's my answer in standard form. Now, for number 14, notice it's saying they're giving you the slope and they're giving you the y-intercept. So our basic equation is y equals 6x minus 3. But again, that's not in standard form. So I have to transpose that, and that's going to become a negative 6x plus y. Working ahead here. Negative 6x plus y equals a negative 3. But if they want our a term to be positive, we just reverse all the signs. So that would be 6x minus y equals 3. Now for number 15, we have something a little easy here. Using our vertical line test, is this a function? And the answer is yes, because that vertical line, as we pass it over the face of the graph, only intersects once. Now, if it were a negative slope, that would pass as well. If it was a horizontal slope, that would pass. The only one that it wouldn't pass is if it were a vertical line itself. That would not pass. So we had reviewed that earlier. Okay, let's go up here a little bit and see what's there. How about a parabola? Does a parabola pass the vertical line test? And the answer is yes. Okay, the use of function here. They want us to substitute into this function a 1 for our x. So I think I could do that mentally. 1 squared is 1. 3 times 1 is 3. 3 minus 7 is a negative 4 over here. Now remember, you could also put this in a little t-chart too. And for this one now, it'll be a negative 2. Well, a negative 2 squared is a positive 4. 4 times 3 is 12. 12 minus 7 is 5. And if this is 1/3, I'll do that one here. So this becomes 3 times 1/9 minus 7. So this cancels out, and I'm left up with a 3 down here. So I have a negative 7, and then plus 1/3. Well, can you all see that's going to be a negative 6 2/3. Or if they wanted a mixed number, that would be 18 also equals a negative 20/3. So that was a little tricky. So once again, we're squaring that. That gives us 1/9. 1/9 times 3 is, you cancel out the 3's there, this becomes 1/3. So it's a negative 7 plus 1/3 makes, you got to take 1/3 away from that, a negative 6 2/3, or that's a mixed number. This is an improper fraction. Okay, now for this one, they're asking us to find the domain. Now in this one, they're asking us to find the domain. Well, remember, there are arrows, and domain are x values. So using interval notation, it would go from negative infinity to positive infinity. Now for the range, it's coming up from negative infinity. It's going all the way up to, I guess we can call that a 1. And 1 looks like it's in the set, even though there's not a dot there. And you put a bracket, indicating that the 1 is actually there. Now, in finding the domain of this function, we have to equate our denominator to 0. So let's do that up here. 2x minus 1 equals 0. Transpose that, x equals 1/2. So if x were 1/2, that would make this denominator a 0. So as we mentioned in our other video, it's going to come from negative infinity up to 1/2. But 1/2 is not included with this in the set, and union with 1/2 on that side, but again 1/2's not included, to positive infinity. All of the numbers, all real numbers except 1/2 are okay. If it were 1/2, it would make our denominator a 0, and that is undefined. Okay, so the following graph shows the height in feet of a ball thrown in the air by a small child. Let's see what else they want here. Okay, I'm glad it's a small child because then the numbers are rather small. Okay, let's work this out here. So how high is the ball after 2 seconds? So we look at 2 seconds, and it's at 4 feet. What is the approximate height of the ball at its highest point? Ooh, that looks like 4.5 feet. And after how many seconds does the ball hit the ground? Well, it looks like it's hitting the ground here where this is 0 at 4 seconds. Okay, we did all of that in 25 minutes. It took me longer because I was doing some work and figuring out things on the side. But that's a pretty good typical test, and good luck on yours.